Okay, so now that we have that Descartes rule of signs, we are going to expand on it and use it to help us figure out all the real zeros. So one of the methods we could normally use is factoring. All right, so this one, it's not factorable, and I can show you why. So the only way that you would factor something like this is by grouping, and you would take out a GCF, so you could take out an x squared, and that would leave you with x minus 1. And then here we could take out a GCF of 2, and that leaves you with x plus 2. So the only way that factoring by grouping works is if these values in parentheses match. All right, so this is not something that we can do. Factoring by grouping does not work for us here. So since we really don't have any other options, because we can't use like the quadratic formula or anything, because this has the third power, we're going to have to just kind of guess. And we can use that synthetic substitution that we used in the previous section, but technically right now we have an infinite number of possibilities. So we need somewhere to start, so we're going to use that Descartes rule of signs to find a good place to start. Okay, so the first thing you want to do is identify how many zeros there are supposed to be. The degree is 3, so there's supposed to be 3 zeros. Okay, so we know that, and that's going to help us make our chart like we did up here. Okay, so now we want f of x, and we're going to see how many sign changes there are. Okay, so there's a sign change right there from positive to negative. There's another sign change from negative to positive. Okay, so there could be 2 or 0 positives. All right, so we know that. Now let's take f of negative x. Okay, so if I plug in negative x into an odd power, it actually does change the sign. If I plug a negative x into the even power, it does not change the sign. If I change an x into here, it will change the sign, and then nothing will change about the 4. Okay, so no change, there's a change. All right, so this is going to head us in a good direction here. So we only have one sign change, which means we are guaranteed to have one negative solution. Okay, so we're going to look there first. We're going to try to figure out what our negative solution could be. All right, so we're just going to start testing some of the different negative numbers. All right, and our first negative number would be negative 1. So we're going to test negative 1 by using synthetic substitution and see if it works. All right, so we're kind of compiling some stuff from previous sections here. So set up your coefficients. So you've got 1x cubed, negative 1x squared, 2x plus 4. And at least we know where to start. We're going to just keep testing negative values until we get one that works. Okay, so we bring down this 1. Multiply these two together. 1 times negative 1 is negative 1. Add these, I get negative 2. Negative 1 times negative 2 is 2. Add these, I get 4. 4 times negative 1 is negative 4, and that leaves me with a remainder of 0. So that's actually a very, very good thing. The fact that I have a remainder of 0 means that negative 1 is one of my zeros. Okay, so I've got one of them. I have x equals negative 1. I guessed correctly. If that didn't work, you try negative 2, try negative 3, just keep going until you hit one, because I guaranteed that I have one negative value for sure. So what you're doing is not in vain. You will hit a negative solution eventually. We were just lucky enough to hit it on the first try. So now what I do is I rewrite, this is 1x squared minus 2x plus 4 with a remainder of 0. So now I can factor this down and find the rest of my zeros. Okay, so this actually does not factor, and you could try it, but it would fail. So what we're going to do is do the quadratic formula. All right, so we're going to do x equals negative b, which would be a positive 2, plus or minus square root of b squared minus 4 times a is 1 times c is 4, and then all over 2a, so 2 times 2. All right, so I've got 2 plus or minus, this is 4 minus 16. Okay, so that's going to be a negative 12 under my square root. Okay, and I can clean this up a little bit. Square root of negative 12, I can bring out a 4. So I've got 2 plus or minus, and then when I bring out a 4, I've got a 2 left over, and then I still have a 3 underneath the square root. All right, and then all over 2, so I can factor everything down and reduce by 2. So I divide everything by 2, and I've got 1 plus or minus, and then I root 3. All right, so those would be your two answers. Okay, so you've got two imaginary answers, and then this is your one negative answer, which means I actually had 0 positives. So I'm going to write my other two, just where I have room over here. So x equals, I've got 1 plus I root 3, and then I also have 1 minus I root 3. So it turns out I had two imaginary answers to go along with my one negative real answer. Okay, so let's take a look at another one. This one, part B, we're going to always test to see if you can factor it first, because if you can factor, your life will be a lot easier. So 4 terms, and grouping is really the only way to go. So this first, I can factor out a GCF of x squared, and then I've got x plus 2, and then plus, and then I have a 9 that I can factor out here. And when I factor out a 9, I'm again left with an x plus 2. So that means this is working. If I get a matching thing like that, that means I can factor by grouping. So I take my x plus 2, and then remember, once that's factored out, my second term is the leftovers. So x squared plus 9. Okay, so we are trying to solve this by factoring, so we set it equal to 0. So I'm going to take my x plus 2, set it equal to 0, and then I can take my x squared plus 9 and set it equal to 0. So this one, when I subtract 2 from both sides, I get negative 2. And then this one, I subtract 9 from both sides, I end up with x squared equals negative 9, and then I can square root both sides. All right, so I get x equals, and then because of that negative, I'm going to have an imaginary number. So when you square root, you always start with the plus or minus, and the square root of 9 is 3, so the square root of negative 9 would be 3i. All right, so you've got two answers there. So this is your one negative real number, and then you've got two imaginary numbers right here. So notice 1, 2, 3, you do have a total of 3 answers, and that's what you'd always guaranteed to have. All right, this last thing we're going to look at is something called the complex conjugate theorem. All right, and that's going to help us set up new equations. So the complex conjugate theorem says this. If a plus bi is a root of p of x, then so is a minus bi. And we can use that when we're setting up some of these polynomials. So this last example, last thing that you're going to do in this section is we're going to write our own polynomial functions that have certain zeros. So we're kind of going to be working backwards from this. Like if we know that x plus 2 is a factor, we can figure out that negative 2 would be a root. This time you're going to be going backwards, and you're going to be starting with the root and then going back up to the factor. So if we know we've got 4 as a root, then that means we would have x minus 4 as a factor. And then we've got 4 minus I. This complex conjugate theorem tells us we must also have 4 plus I. Okay, so here are two roots. We've got x minus 4 minus I, and then we have x minus 4 plus I. Okay, so we have this set equal to 0. So we're kind of working our way from the bottom to the top here. So we are going to FOIL all this out and then figure out what our equation would be. So I'm going to ignore this guy for a second and just focus on foiling these. So just leave your x minus 4 sitting out front and then FOIL all this out. So I'm going to have x times x gives me x squared, and then x times this quantity right here. So I know it's going to be negative, 4 plus I times x. And then this inside here, so again, negative 4 minus I times x. And then this last one, I'm going to multiply this out. So negative times a negative gives me a positive. And then I have 4 minus I times 4 plus I. And I will simplify that in my next step. Okay, so I'm working on simplifying all this out right now. Okay, so again, just leave your x minus 4, just kind of sitting right there. I've got an x squared. When I go to simplify everything up here, I have minus 4x minus 4x. So that is minus 8x. I have minus ix minus negative ix, so those will actually cancel each other out. And then plus, then I work on foiling this out. So 4 times 4 is 16. 4 times I is 4i, and then I have a negative 4i, so those will cancel out. And then I have minus I squared. Okay, so just one more step, and then I'll FOIL in the x minus 4. So I've got x squared minus 8x, and then remember this from previous chapter, anytime you see I squared is equal to negative 1. So I really have minus negative 1. So this ends up being 17, because I have 16 minus negative 1. Okay, so now let's FOIL in that x minus 4. So x times x squared is x cubed. X times 8x is negative 8x squared. X times 17. And then move to the negative 4. Okay, so negative 4 times x squared. Negative 4 times negative 8x. And negative 4 times 17 would be negative 68. Okay, so I'm just going to combine up my like terms, and that will be my equation. Okay, so I just have the x cubed. Here are my x squareds. So that's a negative 12x squared. Here are my x's. And then my constant. All right, so that would be the polynomial equation. So it's almost exactly working backwards of what we were doing before.